Have you ever just stopped and looked around at the chair you're sitting on, the screen you're watching, or even your own hand, and just wondered, what is all this stuff really made of? Well, today we're going on the ultimate deep dive. We're going to zoom way, way past what our eyes can see, all the way down to the fundamental building blocks of, well, everything.
No, really, take a second. What is all this stuff around you? What are you made of? To get our heads around this, let's just grab a few everyday examples.
Okay, first up, the air. It feels like nothing, doesn't it? It's totally invisible, it's a gas. But it's absolutely stuff. It has weight, it takes up space. So what is this invisible stuff made of at its very core?
And then you've got water. A totally different thing, right? It's a liquid. It flows, it spills, it takes the shape of whatever you pour it into. So different from air. And for our last one, let's take something solid and shiny, like a gold ring. You can hold it, it has its own shape. So we've got a gas, a liquid, and a solid. They seem like they're from different worlds, but believe it or not, they're all playing by the exact same set of rules. All right, so how in the world do we start to make sense of all of this? Well, scientists like to start by sorting things. And the first big bucket they put things in is something you see literally every single day. And that big bucket is called a mixture. The easiest way to think about it is like a bag of trail mix. You've got peanuts, you've got raisins, chocolate chips. They're all tossed in the same bag, but they aren't actually stuck together. They're just sharing the same space. Now, even mixtures come in two main flavors. On one side, you have homogeneous mixtures. That's like the air we were talking about. Yeah, it's a mix of different gases like nitrogen and oxygen, but it's so perfectly blended together, you'd never know. It just looks like one thing. On the other side, you've got heterogeneous mixtures. Think about salad dressing. You can literally see the little bits of herbs floating in the oil and vinegar. It's all mixed up, but it's definitely not blended smoothly. Okay, but what happens if we start to pull the pieces of a mixture apart? Like if we could somehow grab only the oxygen atoms out of the air. Well, what we'd be left with is something totally different. We'd be left with what's called a pure substance. This is stuff that's made of only one type of particle, and that's it. So if a mixture is like that trail mix, a pure substance is like having a bag that has nothing but the raisins. Every single tiny piece in that bag is a raisin. But here is where it gets really cool. It turns out that even these pure substances can be split into two final, super fundamental categories. Let's check it out. And those two categories are elements and compounds. Here's the difference, and it's a big one. An element is made of only one type of atom. Think pure gold or pure oxygen. A compound, on the other hand, is made when different kinds of atoms chemically bond together. The classic example is water, H2O. It's one particle, called a molecule, that's actually made of two hydrogen atoms and one oxygen atom all stuck together. The best way to picture an element is to think about Legos. Imagine a giant box filled with nothing but identical red 2x4 bricks. That's it. Anything you pull out of that box is a red 2x4 brick. That's what an element is like. Now, a compound is like this. Imagine you have red bricks and blue bricks, and you have one rule. You must always snap two red bricks onto one blue brick. You do this over and over, making millions of these identical little red, blue, red structures. Each one of those little structures is a molecule, and the whole pile of them is the compound. So everything boils down to these tiny things called atoms. They're the building blocks for elements and compounds which make up everything else. So what exactly is an atom? Let's zoom in one last time. So here it is, the atom. This is the smallest possible piece of an element you can have that still acts like that element. You could take a bar of gold, crush it into dust, but once you get down to a single atom of gold, you can't break it down anymore and still have gold. This is it, the fundamental unit. And if you could crack one open, you'd find three main parts inside. Right in the middle, in this dense little ball called the nucleus, you've got positively charged protons and neutrons, which have no charge. And then whizzing around the outside are these tiny negatively charged electrons. Now, of those three particles, protons, neutrons, and electrons, one of them is the absolute king. One of them holds the secret to an atom's entire identity. And it all comes down to just one number. And this is the key to everything. The number of protons in that nucleus defines what the element is. Period. If an atom has 6 protons, it is carbon. Not sometimes, not maybe, it is always carbon. If you gave it one more proton, making 7, it would instantly become nitrogen. It's like an atom's fingerprint. It's non-negotiable.
So we have these amazing atomic building blocks, and they can get together and rearrange themselves to form new things. We call that a chemical reaction. But what happens to the atoms themselves when that goes down? Do they change? Do they disappear? Let's look at a before picture. These are our starting ingredients, what we call the reactants. Let's say we have some hydrogen gas and some oxygen gas. If we do a quick head count, we see 4 little hydrogen atoms and 2 oxygen atoms. Got it? 4 and 2. Now let's look at the after picture. A reaction happens, and poof, we get our products, which in this case is water. But look, count the atoms again. There are still 4 hydrogen atoms and 2 oxygen atoms. They're all there. They haven't vanished. They've just partnered up differently.
This idea is one of the most powerful rules in the entire universe. It's called the law of conservation of mass. And what it means is that matter can't be created or destroyed. The atoms that existed at the Big Bang are the very same atoms we have today. They've just been endlessly rearranged into stars, planets, air, water, and you.
And that kind of leaves us with a pretty mind-blowing final thought. The carbon, the oxygen, the hydrogen, all the atoms that make up your body were forged inside a star billions of years ago. You are, quite literally, made of stardust. So, knowing that you're built from the same ancient, indestructible stuff as everything else in the cosmos, what does that change for you?